So now we're back for some more chapter 12, and this test I'm going to be testing for independence of proportions, which is very much related to the same questions we were asking in chapter 5 about whether independence was existing in contingency tables that we had. Okay, so first thing I'm going to do is I'm going to find the totals for all of these rows and columns. So for example, I have 21 plus 159 plus 110, enter. And I can find that this right here is 290. All right, I'm going to pause. I'll be right back and fill out all the rest of that table. There we go. Okay, now I'm not going to get too involved into this conditional distribution portion. That's already been gone over in chapter 4. Go see a video. Now, but what I am interested in is right here. If this was independent, that would give us certain expectations to what these values would be. So for example, this would right here be the row total times the column total divided by the total sample size. Now let me go back up and actually, you know what, just for the sake of my own sanity, I'm just going to paste this in here for our own benefit so you can see it. Okay, so this would be 290 times 168 divided by 1362. Right, that was going to work. So 290 times 168 divided by 1362. If these were truly independent, that's how it would work. So that would give me 35.7709. All right. Now I'm going to do that for every single one of these. In fact, I'll show you one more. This one would be 780 times 290 divided by 1362. Which means this one right here is 166.079. All right, I'm going to go find every one of these and I'll be right back. Okay, there they all are. I've got them all typed in. And I did several decimal places. All right, so now I want to conduct the test for independence. All right, so it's down here for example 3. So if I want to do the test for independence, the row and column variable in our particular example were income, income and happiness are independent because that was the row and column variable. In other words, can money buy you happiness? We will find out. And then the alternative to that is that they are dependent. Okay? Then we were given an alpha, so that's step 2. Alpha is 0.05. Yeah, let me put it right here. Then we have step 3, which is our test statistic, which is right there, the chi-square. And now we're going to use the calculator to help us out immensely for this. We're not going to do this by hand, but it is going to be a bit tricky. So what you want to do is you want to go to matrix. It's right above your x-1 button. So you go to second, matrix. Okay, you see how it says names number 1. You want to go to the right so that you're highlighting edit, because you want to edit, select number 1, matrix 1. Now you want to tell it what size matrix you have. So for us, if I look at my matrix right here, it's really 3 rows and 3 columns, 3 by 3. 3, 3. Cool. Okay, now I want to type in my observed values, which are these ones right up here, what I actually saw. So I'm going to type over here 21, enter. 159, enter. All right, let me pause and I'll be right back with all this filled out. There they are. All the values are in there in matrix A for me. All right, now I want to do it again. So go to second, go to matrix. You want to edit again. You can see that matrix A is sitting right there. So I'm going to edit matrix B, number 2. I'm going to make it a 3 by 3 matrix. And I'm going to type in the values I expected, which are all these values, 35.77 and so on. All right, hold on one second. Just FYI, you can actually type in the formula for it and keep all the decimal places if you want. 168 times 426 divided by 1362, enter. And you can keep doing that. Great. Now that I've got them all typed up, I can go to Stat, go to Tests. I'm going to choose letter C, which is the chi-square test, right there. Enter. It's saying your observed is in A, your expected is in B. You go down to Calculate, and there's your chi-square value and your p-value. All done.